Good morning. In today's video, I will tackle about the derivatives, in which I will be explaining on how to solve a real-life problem of derivatives. But before that, what is derivatives? The derivative is the instantaneous rate of change of a function with respect to one of its variables. This is equivalent to finding the slope of the tangent line to the function at a point. The derivatives also are used in math, chemistry, physics, and even in business. Here is the example of real-life problem of derivatives in the field of physics. Mr. Adam is a pilot. He assigned to operate the plane going to Qatar. The plane is traveling at the distance of s is equal to f of t, which is a function of time, as given by s is equal to f of t is equal to 10t squared minus 8t plus 15. What is the plane's velocity and what is the plane's acceleration? Here's the little bit of information that the plane is traveling at s is equal to f of t, and this is the function of time. So it gives us t, which is s is equal to f of t is equal to 10t squared minus 8t plus 15. S is the position of the plane. So we need to find the plane's velocity and acceleration. We lead this part of the question, what is the plane's velocity, as part A, and this part of the question, what is the plane's acceleration, as part B. First, we're going to label what our variables are going to be. So S is going to be our position, V is going to be our velocity, and A is going to be our acceleration. So we need to know the relationship between position, velocity, and acceleration. If you don't already know this relationship, I will write down for you to know. So, the relationship between position and velocity is that velocity is equal to the first derivative of position. So here, detail us that s is actually equal to f of t. So we know that the first derivative of s is going to be the first derivative of f of t. The relationship for acceleration can actually link back to both velocity and position. Acceleration is the second derivative of position, and since we know that velocity is equal to the first derivative of position, we know that acceleration will be equal to the first derivative of velocity. So since s is equal to f of t, we can say here that acceleration is going to be equal to the second derivative of f of t. So once we find our velocity, it will be easier to find our acceleration because we can just take the derivative of velocity. So part A question, we're finding the velocity. So here we can say the velocity is equal to the derivative of s. So s is equal to 10t squared minus 8t plus 15. So here we can take the derivative and get our velocity. So velocity is equal to the first derivative of s, which s equal to 20t minus 8. So that is our velocity. So part B question, we need to find the acceleration. So instead of taking the first derivative again and then taking the derivative, since we've already found the first derivative, we can just take the derivative of velocity to get our acceleration. So if we take the derivative of velocity, we're going to get our acceleration. So the derivative of velocity is just 20. So here, the answer of part B is 20. So this is how we solve physics application question involving the position of velocity and acceleration.